All right, in this video we're going to explore a topic that it really aggravates a lot of students, especially as they're going through logarithms, and this is the idea of a natural log. Okay, and by the way, a natural log on your calculator is ln. Okay? But when you see that ln, it's just a different type of logarithm, but it behaves the same mechanically, and it means the same thing as a regular logarithm. Okay? Now, what I mean by that, well, let's just take a look over here at some examples you would know. For example, this right here, okay? Log base 2 of 8. This is something you know. It means 2 to the what power is 8. You go, oh, that's 3. So this entire logarithm right here represents a value of 3. Okay. Now, natural log has a base of 2.718. And that's actually not the exact value. You look at that and say, where does that number come from? That's kind of arbitrary. Well, if you think back to geometry, this is the best example I can give that's sort of the same. When you're dealing with circles in geometry, this value of pi shows up all the time. Okay? And it's a ratio of the circumference to the diameter of any circle, as long as it's a perfect circle. And so pi just is one of these numbers that shows up, and pi is 3.14. That's how we think about it, but it's one of these never-ending decimals, just keeps on going. It's an irrational number. Well, e is also one of those. Okay? This value e is really 2.718 and some stuff. It just keeps on going. And even though it seems kind of arbitrary at this point, you're going to see some examples in class that show you basically that value comes up a lot when we deal with financial calculations. For example, continuously compounding interest. It comes up a lot when we're dealing with population growth. And so what we've noticed is this is just a really common number. So what we did is we basically made a logarithm that represents that number because it shows up a lot. So you could write it this way right here. Okay, we could write that right there. And that means a log base 2.718 of 10. Okay, it's just like this logarithm here, but you would not automatically know the answer to that in your head. You would need a calculator for that. However, what we decided to do is say, you know what, this right here, instead of writing that out every time, we could write log base e 10. Basically, e just represents this number. That's it. E is just a number. It's not a variable. And, well, if we can do that, why don't we just make up a logarithm for this and not have to write that at all? And that's what this is. And if you type that into your calculator, you type your natural log button, and then type in 10 and hit equals, it'll give you the same answer as that right there. Okay, something you can figure out fairly easily. Now, when we're going to need this frequently is when we're trying to deal with a function that happens to have e as the base, okay, like this one right up here. And what we're going to try and do is still figure out that exponent. We talked before in some other videos that when we're trying to find an unknown exponent, we're going to have to use some type of logarithm. And the logarithm we're going to use always has a base that's the same as that. Well, instead of writing log base e like we do over here, we're just going to use natural log. So the short end of this is every time I want to get rid of an e, I have to use a natural log. Now, for all practical purposes, let's still treat this like all other equations. This part looks such a little challenging, the e part with the exponent, so let's get this 1 out of there. Let's subtract 1. So we get e to the 2x equals 4. Now, if I need to get rid of this base right here, I'm going to have to use a logarithm. We've dealt with this several times, but this time I'm going to use the natural log. Okay? And I'm going to use natural log of the other side. Natural log of e is like saying log base e of e to the something. Those basically go away. They cancel each other out. And I'm left with 2x on this side. And over on this side is natural log 4. Now that again, that's a number you probably would not know off the top of your head. So you just type in ln4 in your calculator, hit equals, and get a decimal. Okay, it's an exponent you shouldn't automatically know. Now whatever that is, I can divide that value by 2. It's probably not going to be a nice number. And I get x equals some sort of decimal. Okay. And that decimal will be whatever you get when you type that stuff in. So those are the basics of using natural log and kind of what it means. Don't let it confuse you. When you see this e, just remember, okay, I'm going to need to use a natural log to get rid of it. And if you see a natural log, then I'm going to have to raise it, exponentiate it with a base of e. We'll get to that in a later video. Okay, so these two things are opposites of each other. They are inverses, which means they will undo each other in an equation.